In this video, we will do another example of finding minimum and maximum points by the first derivative test. So step one is to find your critical values. For h, we've already done this in a previous example. And the next step would be to pick points to the left and to the right of the curve to figure out if the derivative is positive or negative. And again, to recap, the derivative of this function we did before, it was 3 times x minus 1 squared. But basically, I know my critical value is at 1, and I need to check points to the left and the right. And again, I could pick whatever I want. Let's just pick 0 and 2. Usually I'd pick 0 if it's convenient. And then I want to plug these into my derivative. I already know that the derivative at 1 is equal to 0 because that's what, right? If you plug in 1 over here, that's what a critical value means, right? Critical value is where the derivative is 0 or technically undefined too. But in most continuous mathematical functions, it is defined, but not always, but usually. Anyways, so let's go ahead and check, well, what's the derivative at 0? So h prime of 0 is what I want to, another thing I want to know, well, that would be 3 times negative 1 squared. Also, it doesn't matter what the value is, it just matters if it's positive or negative. So obviously that would be positive because a negative squared is positive. So on the left-hand side, we have a positive slope. That also, again, I can kind of visualize that means increasing. And then I need to know, well, what about on the right-hand side? H prime of 2 is 3 times 2 squared. That will also be positive. So here is an example where if there is no change, that means that this is neither a relative or minimum. This would be case 3 of the first derivative test because it means it's increasing, flattening out, increasing again. And if you actually go ahead and look at the graph of this h function, x minus 1 cubed plus 2, you'll see that it actually has a critical value. It flattens out at this particular point, but it doesn't actually change from increasing to decreasing, which means this is neither a min or max. You can always use a graph to check that out. And that point, if I were to plug it in, would be 1, 2. 1, 2 is neither a relative min or max because it has no change in the sign.